This is the Icom IC-7300. It's one of the most popular radios, in fact, probably the most popular radio of all time. Very nice, lovely waterfall display, generally performs very well, but I do have a problem with it. My problem's on 4 meters, so it's not going to affect most worldwide customers as 4 meters isn't available in many areas. But this is a big problem for me, particularly when running it into a linear amplifier. Let me show you what it is. Did you see that? About plus 30 on the peak. Not so much that time, just under S9. That is a serious overshoot problem. So what I intend to do in this video is show what the problem looks like on the radio and quantify it on a spectrum analyzer. So I'm going to switch between the two so that we can fully understand how it looks. I'm going to look at the radio settings, how they affect the issue, what bands the problem's on, and after all that I'm going to explain how to mitigate the problem. Just in case I'm confusing anybody, when I'm mentioning the S meter reading in transmission, it's actually the power scale I should have been saying, which is just below the S meter reading on the same bar on the display. It's just a bit more prominent, the S reading, so that's what I'm calling it, but it's the power is more relevant below that. I've now gone into the meter screen on the radio so we can get some more information about what's going on. Notice that I've got the compression on. If I look in here, there's the compression on. If I hold my finger on there, you can see it's on level 5. Okay, might gain 50%. RF power is at 4%. So it's very low. This is important because I need to set it that low to drive my linear amplifier to make sure I don't get more than 160 watts, the legal limit, out of it. Okay, so I'm going to hit the transmit button. Just off the left there, we've got the TX light on, and I'm going to start the signal generator. There we go, big spike, ALC just moved up just over the red. Nice bit of compression. Switch it off again. And I'll run it again. Big spike, plus 10 again. Okay, but when I turn the compression off, watch this. Fine. So that's the level I've got set on the ALC. It's not too strong going into the radio. Turn the signal generator off again. There it goes. Switch it on. Switch it off. So with this configuration, there's only a problem when the compressor's switched on. So now I've got the output of the radio connected through a 40 dB attenuator going into my spectrum analyzer. And this window you can see is 100 milliseconds of the amplitude versus time. There's the average power down here, and this axis shows the power level in dBm, going up to a maximum of 10 dBm there. And this window is showing the radio, so we can see both at the same time. So I'm going to run the signal generator again and watch what the peak level is from the radio. There we go. And we've got the average power's gone up to minus 7.88 dBm. And it's showing the straight line there. And we can see in the radio window there, we've got about S1 showing. It's actually on TX, so it's that power output we're looking at there. ALC just in the red and the compression on, exactly where we saw the problem before. So I'm now going to enable a trigger on the spectrum analyzer so that it will capture the waveform as the power is applied. Turn that trigger on there. Right, and now I'm just going to turn the signal generator on again. Wow, okay. So we've got a peak there up to, well, probably 4 dBm, something like that. And then it falls back down to the correct level, which is about the -8 dBm that we saw steady state earlier. So yeah, very, very big overshoot there. And now I've turned off the compression. Let's run again. Okay, no overshoot at all this time. So the compressor is definitely causing this issue. Well, in this configuration anyway. I've now doubled the output of the signal generator going into the back of the radio, and turn the compressor off. So now when I hit run on the signal generator, the ALC has peaked up there. There it is in the red, and we've got an overshoot. Okay, let me do that again. Turn the signal generator off. There, it's just triggered on the falling edge. Turn the signal generator on. And we have an overshoot again. So it's not a problem limited to when the compressor's on. It's just when there's an audio level which goes over the ALC level. I'm just going to try the microphone input and see if the microphone can cause the problem. So I'm now talking into the microphone on the radio. You can see the ALC peaking up there and the spectrum analyzer power. Okay, there's the sort of level we've got with a whistle going into the mic. Now I'm going to flick the microphone. Wow. So there you can see we've gone up to nearly 5 dBm. Huge overshoot on the signal. So, well, with the microphone, if the microphone gain was up even more, then there'd be an even bigger overshoot, I guess. So, problem is definitely not limited to the accessory port, which is where I'm injecting the signal generator, or when the compressor's on or off. It's just when the compressor's on, it's far more likely because it's increasing the gain of the audio. Right, I'm just going to change bands now to the 6 meter band, and I'm going to repeat the test there to see if there's the same problem. Compression on, TX, there we go, and I'm going to turn the signal generator on. If I can find it here on the screen, there we go, run. Looks right to me. Okay. Interestingly, the ALC's lower, but the compression's right up. So let's stop again. Right. Here we are with the spectrum analyzer window. Signal gen on. Tiny, tiny overshoot. Off. Reset on again. Yeah, nothing there really. Turn the compression off and go again. Not sure what that dip is that's happening the second time. Could be something to do with the signal generator. Off. On. Yeah, nothing. Off. Okay. So no problem on 6 meters at all. So in summary, the problem only exists on the 4 meter band. I haven't noticed the issue on any other band at all. So most of the world won't be affected. The overshoot though can be a huge 13 dB when I'm on that 4% output power setting. So that's the equivalent of going from 1.6 watts to 31.6 watts. So that is quite a large overshoot, to say the least. Compression makes the problem more likely, so if you can, turn the compressor off. As you turn the output power off, the problem gets less. I haven't shown that in this video, but it makes sense. If you imagine the power turned all the way up, you can't get any overshoot on that. Unfortunately, this problem makes the radio unusable with a linear amplifier on 4 meters, or generally unless you use an external microphone with an AGC. So when I'm using 4 meters, I run all of the audio through a computer and I compress and limit it within there and send it into the auxiliary, the accessory port, and then I know I'm going to get a reasonable performance. But without doing that, I wouldn't run it on a linear amplifier certainly, and probably not normally on 4 meters. A real shame, and it's something that I'd like to look into to see if I can correct in the radio at some point. I hope you found the video interesting and perhaps a bit of an eye-opener. Please let me know in the comments if you've seen the problem yourself, or maybe you have other workarounds for it. And thanks for watching. Hopefully see you next time.